In section 4.1, we're going to start off by talking about composite functions. Okay, so I have a definition given here, and I'm not interested in whether or not you can give me the definition back, but I want to talk about this definition. If we start out with two different functions, function f and function g, then the composite function of these two, which we read like f composed g, or f composed with g of x, is equal to f of g of x, okay? And this will be clearer in just a minute when we explain it, but that's what a composite function is. It's where you evaluate some function, get an answer, and then evaluate the next function at that answer, okay? Something I want to make clear here. When we talk about composite functions, this little circle here, this open circle, does not mean multiplication. Okay? It does not mean multiplication. It also, whenever we do composite functions, the order in which we write them, or the order in which we perform the composition is very important. And then I want you to also just keep in mind that when we are doing composition functions, we're doing nothing more than evaluating the function. Okay, so let's get started. Here in this first part, I want to be able to form my composite function. So I have an example here. We're going to call this example 1. Okay, and I have two functions. The first function, f of x, is given by this. The second function, g of x, is given by this. And I want to be able to find f composed with g at 1. Now when I rewrite this with the first function, the f, on the outside. So I write it as f of, and the second function, g of x, like that. So I start reading, as I read this from left to right, that's how I write it, from left to right. Okay, so the order is the first function goes first, the second function goes second. So now that I have this written, I'm going to find f of g of x for 1. So the first thing that I'm going to do is I'm going to find the inside function. Remember that was g of x. So I'm going to evaluate g of x at 1. G of x is 4 times 1, which gives me back 4. Now I'm going to go evaluate the second part of my function, the f part, at this new value. So I'm going to evaluate f at 4. Okay? Here I know that f would be 2 times 4 squared minus 3. So that would be 16 times 2 minus 3 gives me 29. So my answer would be 29 when I f composed g at 1. In other words, I got to evaluate the inside function, and then I evaluate the outside function at this new value. Okay, let's try that again. Remember, order is important. This time I have g composed with f. So if I read this from left to right, I start with the g on the outside, I write the f on the inside, and that's how I'm going to perform the function. So first thing I need to do this time is perform f of x, or evaluate f of x at 1. So f of x at 1 gives me back 2 times 1 squared minus 3, which would be negative 1. And then I'm going to take this negative 1 and plug it into g. So I'm going to evaluate g at negative 1, and I get 4 times negative 1, which would be negative 4. So the answer would be negative 4. Okay? So the order was important here. It says g composed with f. You start on the inside and you work your way out. Now let's try one more example. This time it's f composed with f. Even though I'm composing my function with the same original function, I will end up getting a different answer. Okay, so we write this as f composed with f of x. So I'm going to evaluate f of x at negative 2. So f of negative 2 would be 2 times negative 2 squared minus 3, which would give me, let's see, 4 times 2 is 8, minus 3 would be 5. And now I'm going to go evaluate the outside function, which in this case happens to be f again. But this time I'm going to evaluate f at 5. Okay? So I say 2 times 5 squared minus 3, and that gives me 47. So when I do the composition here, I actually end up with the answer 47. So it's just a two-step evaluation. Working from the inside out, I evaluate the inside function first at the given value, and then I go through and I evaluate the outside function at the new value. Okay?